Welcome to Natural Habitat Adventures Daily Dose of Nature. Today's topic, the beauty of bogs, a visual journey presented by NatHab expedition leader Charlie Reinertsen. I'm your host, Rob Mess. Thank you all so much for being here with us today. Over to you, Charlie.
Thanks for that introduction, Rob, and thank you everyone for joining us this afternoon. I'm calling in from Adirondack Park in Saranac Lake, where our snowpack is rapidly disappearing. We've got 2.5 inches of rain today, so it's a very wet day in the Adirondack. So it's pretty fitting that we're going to be talking about wetlands today. And one of the special things about Natural Habitat Adventures is that their travel adventure helps to support ecosystems and helps to support ecotourism. And that's really made possible in large part with their partnership with World Wildlife Fund. And one of the big topics for conservation at large in the world is what we're going to be doing with our peatlands and how we're going to be conserving and protecting them. So that's what we'll be talking about today. Just to give you an overview of where we're headed, I'll introduce myself, I'll give you a Peat 101, and then we'll launch into a photographic journey through one of Earth's rarest ecosystems, and that is the peatland. And we'll talk about what that is and what it means and why everyone should know about them and get excited about them. So thanks for tuning in today. Just a little shout out to some of the trips that you'd be able to see peatlands on through Natural Habitat Adventures. Anything in Canada would encounter peatlands or wetlands, but wetlands are all over the world, and we're going to see a map today of where these ecosystems exist. And they are not talked about extensively, but there are a number of trips that you'd be able to see them on. So I'll be able to highlight that once we see the map. But just to dive in a little bit, I've been working in the field of science communications for the last decade. I studied biology and researched the ecology of riverine turtles. And then I spent the last 10 years working in various forms of writing and education, and most recently on the Climate Solutions exhibit at the Wild Center. And a huge part of that Climate Solutions exhibit is on peatlands. And that research for that project got me really excited about this ecosystem, and now it's become a big part of the work that I do on the Northern Peatlands project. My photography work has brought me all over the world and put me in touch with some incredible partners who I've been able to work for or work with, and Natural Habitat Adventures and World Wildlife Fund are two partners who have been incredible to work with, and I'm fortunate enough to be able to guide about 4 times a year. And I do trips in Yellowstone National Park, Grand Teton National Park, and in the butterfly wintering grounds, the monarch butterfly wintering grounds in Michoacan, Mexico. But today we're lucky enough to be visiting this ecosystem, these northern peatlands, digitally through photographs that I've been taking, in particular in the last year. And before we dive into this ecosystem and what it means, we're just going to do a little bit of Peat 101. What is peat? It's the organic material that's formed when plant material accumulates in a saturated environment. So it takes lots of water, lots of built up vegetation, where it's an anaerobic environment that slowly decomposes, and that's where we start to form peat. This graphic is from graduate student work from North Carolina State University, where there are an abundance of peatlands. But on the right-hand side of this graphic, you're seeing what's called a core. And when you're in a peatland, which is a wetland that has all this organic material, you can take a core of that dense vegetation and start to study it and look at it. And the substance, as you get below the surface of the living plant material, once you get into the dead and decaying material that's compressed and waterlogged, that's what we call peat. And a peatland is wherever peat is being formed. Now, peatlands are, in a lot of ways, they're one of the structures on the environment that you can actually kind of sense where glaciers have been present. So if you're in a really mountainous area, most likely you can see evidence that glaciers have impacted those geological features. And peatlands are another example of places where most likely the glaciers scoured the landscape, and then slowly that landscape, as the glaciers retreated, that landscape pocket filled with water, and then vegetation starts coming in on the edges, and dead and dying vegetation builds up and builds up to the point where all of a sudden you have all this submerged dead material that's so thick that it's not decomposing in the right way, and then you start to form this very special peat. And we'll talk about why that's special. But this graphic on the left just shows shallow open water and then accumulation on the edge, followed by a bog, a transitional bog where you have vegetation on top and lots of water underneath, and then eventually a raised bog. So there are many different types of peatlands, and this graphic should help kind of categorize some of these. This is not comprehensive. This is just to start to put some names to faces, if you will. So if the large umbrella is wetlands, within wetlands you have peatlands, marshes, and swamps. And you can have, of all of those, you can have coastal or tidal or inland or non-tidal of those categories. But then underneath peatlands, you've got your fens, your bogs, your pocassins, your mires, and all of those are designated based on where the water source is coming from, which also dictates the pH or the acidity level of these environments, because often these are incredibly acidic environments where plants have become perfectly adapted to be able to exist in these environments. And so you'll find plants in fens and bogs and mires that don't exist anywhere else in the world. And that makes peatlands a biodiversity hub. So the next question, where can you find peat? Peat is found all over the world. This graphic, it's hard to zoom into, but you can see here that there's huge swaths of peat in the northern North America and up across Russia. And then you can also see that there are little red dots all the way across the world. And so again, it's wherever you have this buildup of dead and decaying vegetation that forms this really dense, high organic content that is called peat. Now, it's one of the most rare ecosystems in the world. While it is found everywhere in the world, just about, it only covers 3% of Earth. And this is the stat that's really astounding. It stores 50% or more of Earth's soil carbon. That's twice as much as our global forests. So that is an incredibly important piece of the story when we're talking about climate solutions. The other reason why peatlands are so important, that we care about them and take care of them, is that they're biodiversity hotspots. This is just a list of threatened and endangered peatland species. And this was put together by a graduate student, again, at North Carolina, Madeline Baldwin. And it just starts to give you a sense of this incredible diversity of organisms that rely on this very rare ecosystem. And tying back into that idea of peatlands being a carbon sink, they help keep our planet cool. And so just to give you a little bit of a Climate Solutions 101 for how that's possible, there are two primary pathways for climate solutions. We can reduce our CO2 and carbon dioxide equivalent gases emissions, and then we can also store more carbon. So this is a graphic from Project Drawdown, which is one of the organizations working on climate solutions globally. And on the left-hand side, you're seeing current sources of our emissions that contribute to greenhouse gases from electricity production, food and agricultural and land use, industry, transportation, all of those items on the left. And on the right-hand side, you're seeing sinks. So those are ways that we can store more carbon. And as you can see, there are land sinks, and then there are coastal and ocean sinks. And so there's a huge opportunity there where if we can restore habitat that's been degraded, we can start to increase the capacity of our natural ecosystems to cool our planet. So storing more carbon comes down to our ability to support and restore our natural ecosystems. Just getting that graphic one more time. And just to hone in here a little bit more on why are we talking about peatlands so much in terms of climate solutions. Again, from Project Drawdown, they've got this comprehensive list of all the solutions that we can put in place right now to be able to address climate change. And they organize them in a lot of different ways, but one of the ways they organize them is by the impact that that individual solution will have on the whole problem of tackling climate change. And peatlands are within the top 20. And right here it's showing that peatland protection and rewetting in one particular scenario could remove 25 gigatons of carbon dioxide equivalent. And so just to give you a sense here of this full list, you know, just restoring our global grasslands would only get us 3.35, also an incredibly huge amount, but it just puts into perspective why peatlands are so important. And we should really be hearing more about them as climate heroes. And yet a lot of the news coverage, I'm sure you've heard of permafrost, which is this idea that as some of our peatlands that have been completely frozen since the last ice age because of climate change, those areas are melting and warming up, and they're releasing incredible amounts of greenhouse gases, which is really scary. But instead of painting peatlands as the villain, we can be painting them as the hero, because there's such an opportunity to be able to start restoring these ecosystems and bringing them back to life in areas where perhaps it used to be an agricultural area that is no longer used now. And if we simply re-wet that land and do some very basic restoration efforts, we can return them to this huge carbon sink. And just to give you another sense, Project Drawdown does a great job of kind of showing how you can really be a part of the solution. And the idea is that 15% of our peatlands have been degraded, but the good news is that we can restore them and start to prevent forest fires and cool the planet. So just to kind of give you a quick rundown of why are peatlands so important and why do we want to talk about them today before we dive into this presentation on peat. So everything that we're about to dive into, all the content, the photographs, are part of the Northern Peatlands Project, which I started about 2.5 years ago, starting to research peatlands. And you can follow along and get monthly updates on what I'm up to. And I'll kind of share the current status of this work as we go through the rest of this presentation. So specifically today, we're going to be talking about northern peatlands. So right here, this huge red swath extending all the way up into Alaska through most of Canada. And today I'm calling in from Adirondack Park, where all of the work on this project is based. And zooming in here, Adirondack Park takes up a huge portion of New York State. You could fit Glacier, Yosemite, and Yellowstone, all of those parks inside the perimeter of Adirondack Park. It's a combination of state, public, and private lands with wilderness designation, so it's heavily protected. And the particular place that we'll be looking at today is Spring Pond Bog, which is actually conserved by the Nature Conservancy. This particular land was being looked at for development of peat for a fossil fuel for heating. And so the Nature Conservancy and other advocates came together and conserved this particular location. It's the second largest peatland in New York State. And so that's the location of where we're about to explore. And right now I'd like to kind of take you through spring and summer and then transition to some of the fall shots. And I'm still in the process of editing a lot of photographs and video that I've been taking this fall, and there will be a lot more content coming out this winter, but this is the location that we're talking about. And this picture in particular, you're seeing a spring sitting in the middle of this peatland. And all of the surface, in the distance there, you can see the tree line and all the trees surrounding the peatland. And as soon as you get off of that tree line and down onto the flat area, you are standing on a layer of living sphagnum moss and some mixed sedges, and a couple trees like black spruce. But then underneath that is just dead and decaying material that makes up the peat, as well as pockets of water underneath the surface. It's kind of like walking on, like, if you've ever seen those magic carpets or floating devices that you can stand on in the water. When you walk out onto a area like this, it feels very much like you're walking out on that. Here's a lower perspective on another spring that's within this particular area. And if you look on the left-hand side of this image, you're really starting to see how this peatland comes right up to the edge of the water. The water is really tannin stained, really highly acidic, and all the plants that live here are adapted perfectly to be able to withstand having wet roots and vascular systems, and also adapted to really acidic environments. This is the trail that I take to be able to get out to this particular area. To be able to get to this place, I have permission from the Nature Conservancy, so it's about an hour drive to get to a gate, to be able to get through that gate, and then another 45 minutes on a dirt road, and then I hike about 45 minutes out onto a peninsula where I'm overlooking the peatland. And on the left-hand side here, you're seeing a mixed conifer and deciduous forest. And on the right-hand side, you're seeing the peatland. And this picture was taken in early July. And you can see that the sphagnum moss is mixed with red and with green. And when we come back in the fall, I'll bring the same type of composition up, and we'll start to see how that sphagnum moss changes through the seasons. Here we're getting another down-facing, straight down perspective on another spring in this area. And on the left-hand side, you're actually starting to see wildlife trails cutting through the peatland. And all of these photographs are taken, most of these photographs are taken with a drone, because it allows me to explore this ecosystem without negatively impacting it. Because while these plants are really hardy in that they can withstand so much moisture and high acidity, they also are susceptible to disturbance. And so for the vast majority of my trips, unless I'm with a researcher who is conducting research out on the peatland, I am staying on the peninsula that juts into the peatland and staying on dirt while I fly my drone around and explore the area. And it's just been really incredible to get to know this place and to start to see these particular bodies of water kind of take on personalities of their own as I see them time after time, and see them through different weather patterns and different seasons. And every time that I'm processing my images, I learn something new about this place, which has been really phenomenal. So now we're transitioning over to these fall pictures. And in particular, this is from a photo shoot where we had just had a snowfall the day before, and then the next day it started to melt with the sun, and then I went out in the late afternoon so that there was still a little bit of snow left in the shadows, but it had melted off. This area in particular is the last stretch of dirt road that I cross over the river that actually is part of the larger watershed. And this is an image of where I park to be able to go onto the trail to get out to the peatland. So it'd be heading towards the upper side of this image here. And this picture is nice because it gives some context for where I'm hiking. So I'm hiking through these woods. It starts kind of in this more deciduous forest and eventually transitions into a conifer forest and extends out way out onto that peninsula. So that's the location where I'm flying the drone from and getting really close-up shots. There's a little boardwalk, and this is a place that the public can visit, but you have to request a gate pass from the Nature Conservancy. And I have special permissions from them to be able to capture drone photography and videography, which is typically prohibited at the location. But because I'm doing it for conservation purposes and providing TNC with imagery, they're allowing me to do this work out there. But another thing I'll point out is that you can kind of see here that the peatland itself, which is kind of that red and yellow field, has really changed colors into the fall season. And so you'll start to see that even more here. This is one of those springs you might start to recognize the shape of it at this point. I kind of in my head think of this as the wolf of Spring Pond Bog. It kind of looks like a wolf a little bit to me. But this little series here just punches in closer and closer to this particular spring and ends here. And if you look really closely in the shadows, you can see some snow pushing up against those bushes and black spruce. These black spruce can be hundreds of years old and only be 10 feet tall because it's such a harsh environment to be able to survive in. Here's another look at that same spring, just getting different perspectives. And one of the things I've been realizing through this work is that when I point the camera straight down, it creates a really abstract view of the peatland. It's beautiful, but it's hard to wrap your head around. So I'm going to transition to the next slide, and it's going to be a down-facing view on this same location. So, oh no, sorry, it'll come up later. This will be the one that transitions down. And just to point out here on the left-hand side of this image, you've got a wildlife trail that kind of splits off and heads towards those trees. And here's the aerial version of that. There's the down-facing, which is what we call nadir, N-A-D-I-R imagery. So it starts to just kind of create this abstract view and creates negative shapes with the water against the peatland. And just to transition back and forth, I'll share a link at the end of this so that you can see all these images on your own time and maybe a little bit higher quality without streaming the video. But I've just been completely obsessed with this habitat and this environment from a visual perspective and from an ecological perspective. It's just been something that just continues to give me so much curiosity and wonder. And it's definitely something where the more I learn about it, the less I realize I actually know about peatlands. And so it's been a really fun process of discovery. This is another of my favorite bodies of water in the peatland to be able to photograph, and it'll transition to the top-down view again here in a second. So look at that little piece that's jutting out into the body of water, and now we're looking down over the top of it. So that's almost the whole spring, but I like this kind of tighter composition because when I zoom out all the way, it almost looks like a Pac-Man, and I find that to be a little bit distracting. So on this image, you're seeing the snow kind of hiding on the north side of all the plants. And those little dots in the water are actually lily pads. I've been able to zoom in on that and figure out that those are actually lily pads in that water. And here, getting to be in this place and see how the different light opens up new possibilities for photographing the bog. I hadn't been able to spend very much time at sunset until this photo shoot. So this was really fun to be able to just capture different angles and different compositions of this place than just morning light. And here, this image is really showing that wildlife trail extending straight over to that spring. And this one I really love because it's starting to give you those three characters that we've really been focusing on, those springs. I just find that the edge of the water meeting the peatland it tells such a nice visual story, and it helps you kind of get a little bit of a foothold on what it is that you're looking at. And so these are those 3 bodies of water that we've been looking at so much. And in the distance is the peninsula that I'm flying the drone from. So here, I'm guessing the drone is probably 2,000 feet away from my station. And just another view of those 3 bodies of water. And this one, I love how the deciduous trees in the foreground are just beautifully, softly lit. And the springs in the background just have that beautiful blue. And one of the things that I joke about is that in this area, everybody is so focused on exploring the high peaks, which are their own incredible environment and have such incredible ecology, but so few people spend time in the lowlands. And so I'm a big advocate of getting out into our wetlands and exploring what those places have to give us. So this is kind of a throwback to one of the earlier images we were looking at, and that's the trail that I walk out to. And I was just so lucky to be able to capture this moment because there's still these holdouts of snow in the forest, but then you've got this carpet of just vibrant red peat or sphagnum moss in the peatland. And right on the edge where the sphagnum meets the trees, it's turned into this beautiful kind of orange yellow. So it's just been so amazing to see how this ecosystem responds to the seasons as well. And the next chapter in this work is getting a little bit more up and close and personal with what's happening on the ground. So this gives you another textural sense of the sphagnum moss, and then in the dead center is a pitcher plant. And pitcher plants are carnivorous plants. So this plant in particular has this digestive fluid that's sickly sweet, and it attracts all of these pollinators who are drawn to nectar to feed. And they come down, they kind of walk down that open tube, and they never come back out because they start to drink. There's a little bit of toxin in that fluid, and they get essentially drunk, and they can't climb back out, they can't fly back out, and they just drown in this digestive fluid, and the plant breaks those insects down and then uses that as energy. So it not only can photosynthesize, but it also can consume prey. So this just starts to give a sense of how wild these ecosystems are and the types of plants that are living here and nowhere else. So it's really a haven for biodiversity. On this picture, you're actually seeing 2 moths inside the mouth of the pitcher plant. And in particular here, you're seeing this is end of season, so these pitcher plants are taking on a bit more red color. Normally they'd be a bit more green, and the leaf at the top, when they start to senesce, when they die back, it starts to fold back like it is now. But typically that hood would kind of protect the opening of that pitcher plant so that the toxins don't get diluted by rainwater. But this is end of season, so it kind of opens up these opportunities for photographing the drama of what's happening because they have started to open up towards the end of the season. And this kind of gives you just a sense of how much the sphagnum moss just is like a sponge, and you can just press down into it, and then water eventually will cover your hand. And here on this unseasonably warm day in November, this dragonfly landed on me, and you can actually see a couple of bug bites on my hand because even in November there were black flies, which is pretty amazing. This is a really close-up macro shot of the sphagnum moss as it's changing colors through the season. And one of the amazing things about this is just a fun fact about it is that in World War I, it was used to dress wounds, and that's because it can hold 8 times its weight in in absorbed fluids. So typically it's absorbing water, and it can be 8 times as heavy as its own mass with the absorbed water. And in World War I, it also has antiseptic properties, which made it a really good bandage at that time. So the next chapter of this work is also going to be working from a high wing plane. There's a partner that I've been working with here to be able to make these flights happen. And in addition to that, because of this work, Nikon has been sending me all kinds of equipment to go test. And so the drone is amazing for a lot of perspectives, but you can't get that high angle. This is looking at, again, that same spring pond bog location, but it gives you just a long view of how expansive this peatland is. Basically everywhere you see some snow in that center of the frame is where the peatland exists. So we'll be seeing more from the high wing plains soon in this project as well. But just to wrap up here in our conversation about peatlands and how important they are, these are a couple suggestions of what Project Drawdown notes that people can do to be able to support our peatlands. You can find out whether peatland protection is part of the sustainability plan of the company that produces your favorite manufactured food item. If not, you can reach out or use social media to encourage a change. So the idea that how we use land, in particular, how we use land for agriculture, can impact our peatlands. So if we start to look into our chain of where we're getting our food, it's possible you can sleuth out whether or not that food is being produced on land that was once a peatland, or that could be produced in a way that also supports peatlands. And then also you can contribute to environmental organizations that are working to advance the protection of peatlands. In addition, I'd love it if you would follow the Northern Peatlands Project. You'll hear all of these stories and more, and just follow along with my journey in getting to know these places. And this project is so important to the story of climate change in particular, because if you go back to that map, Northern peatlands exist in this swath all the way through Canada, and I'm at the southernmost point in Adirondack Park. And so the observations that scientists make here, who I'll be interviewing, and the images that I'm collecting are going to start to paint a story of what's going to happen to our peatlands further north, because the impacts of climate change will impact these ecosystems and continue to do so further and further north. So the changes we see here are going to be the changes that we see in Canada as well. So you can scan this QR code to be able to sign up for two-line tracks, and you'll be able to get stories like these. This Unlocking a Bird's Eye View talks a lot about some of the regulations and hurdles that I had to be able to use a drone to be able to do this work, because there are a lot of protections in place to make sure that people are flying responsibly. And so that post really dives into the nuances of the partners that I've been able to work with, and some of the regulations that I've been able to work with to be able to do this work. And if you'd like to get in touch, I'd love to hear from you. You can reach out to me by email or follow me on Instagram. That's Two Line Studio on Instagram. And you can scan this again to get those stories from the field. So thank you all so much for tuning in and joining me to talk about one of my favorite things in the whole world, which is bogs and peatlands. And I hope that you're inspired to learn a bit more about peatlands and perhaps even find a way to support them as well. So thanks for tuning in, and I'll take a few questions here to wrap things up, wrap our time up together.
All right, Charlie, thank you. Now, before we start with the question and answer session, I would like to remind everyone that you can submit your questions via the question field in your control panel. All right, let's get to some questions. So, is there an overlap between peatland and permafrost? And will the melting of permafrost reduce peatland and release more CO2?
Yeah, so the idea there is that there are some peatlands that have been frozen ever since the last ice age. And right now, because of climate change, areas are thawing that have never thawed before. And so when peatlands thaw, the initial phase is releasing a lot of greenhouse gas emissions. And so that is the part of the story where we're concerned about those peatlands that are in the northernmost reaches of the earth that are releasing greenhouse gases as they thaw. So permafrost is permanently cold, never thawing peat, essentially. And because we have a warmer climate, those areas are thawing. But the idea is that about 13% of our global peatlands have been degraded, whether that's drained and converted to strip malls or drained and converted to agricultural land. And a lot of those areas are great opportunities for restoration. And so if we can restore those peatlands that are not part of the permafrost equation, we can offset what's happening to the peatlands that are thawing. And ultimately, those thawing peatlands will stabilize and they won't be continually releasing greenhouse gas emissions. But it's definitely part of the equation. But the big idea here is that in areas where peatlands exist, we need to protect them and we need to restore them when and where possible if we're going to meet our climate objectives. Yeah, thank you for the question.
So, is most of the peatland in the extreme northern hemisphere?
Yeah, they're in terms of the largest surface area of peat, the northern hemisphere has the vast majority, but you can find peatlands at every latitude, longitude on the planet. It's just that there are some places that they're more rare. It's basically wherever you have standing water and dense vegetation and dead and dying vegetation that accumulates to be able to create that peat. Yeah, thanks for that question too.
So, if the water is a little bit higher in acid, can animals still drink out of them, and how do they take that?
Yeah, it's a good question. I need to do a little reading about that. I haven't read anything that says that they have any issue with drinking the water. The big thing around drinking water and peatlands and wetlands in general is that our water is clean and ready to drink because we have wetlands, because we have peatlands. They're this incredible filtration system that remove toxins from water. And so water that's been part of a water table that has a peatland or a wetland or bog or fen is filtered and much cleaner to drink than other water. But your question about the acidity specifically, I'll have to look into whether that has any impacts. I'm not sure.
So, do we know what kind of wildlife in general lives in the peatlands?
Yeah, so all of the wildlife, excuse me, that live in the Adirondacks will use this ecosystem as well. There are no animals that necessarily avoid it. You'll see moose walking across the peatland. The peat can actually support them. And deer, there's a lot of forage out there, and there are a lot of medicinal plants that indigenous peoples have collected and used for medicinal purposes that live in the peatland and in bogs. But in terms of animals that are specifically native or endemic to peatlands, there are a few bird species that rely exclusively on peatlands to be able to nest and to have a particular phase of their life cycle. And so there's the black-backed woodpecker is a bog-specific species. The gray jay also is really interesting. They're one of the birds that will overwinter here, and throughout the summer they will make incisions in the bark of trees and use their saliva to stick seeds into that incision and glue them in, and then their hippocampus, the area responsible for memory, actually expands during this period of time where they're caching all of their seeds. And then throughout the winter, they're going and they're tapping all of their caches to be able to feed and survive the winter. So there are a number of species that rely on this ecosystem, and without this ecosystem, those species would not exist.
Do we know if beavers have a positive or negative effect on peatlands?
Yeah, so beavers have a huge role in wetlands generally, because they control so much of the water flow, the hydrology of an area. And peatlands require a lot of water to be standing in one area and not released from that area. So beavers can contribute to water being held in a particular area. Beaver ponds could ultimately transition if they have enough vegetation in that area, and eventually have so much accumulated, they could be ultimately hundreds, thousands of years from now become peatlands. So they do have a huge, very tight relationship with these areas. I haven't seen beavers in this particular area, but I have seen beavers in the exit. There's a stream that comes out of the peatland, and there's definitely a lot of beaver activity there. So they're an integral part. And one thing that actually reminds me, this has been on my reading list for a while. I just finished it. It's called Swamplands, and it's by Edward Struzik. And he's a researcher, and it does a great job of being able to talk about swamplands and all the creatures that rely on these ecosystems, and a lot of really interesting tidbits from that one.
Great, thank you. Now, how deep are most of the bogs? Are these bodies of water getting smaller or bigger with time?
Yeah, so that's a really good question, and kind of going back to the difference between bog, fen, and a mire is that they're either fed by precipitation or they're fed by groundwater, or a combination of the two. And the ones that are fed by groundwater, or precipitation, if the climate starts to shift in an area to have less precipitation overall, which is the trend for this area, you could start to see changes in the water table, changes in precipitation that would lead to essentially these areas starting to dry out. So there is a lot of concern around water rights and what's happening to water in the area. Adirondack Park in particular has more than 500 dams in various states of decay or usage. So how water moves through this ecosystem is a huge part of maintaining, restoring, or protecting peatlands. This one in particular, the Nature Conservancy owns all of the forested lands surrounding the peatland, and technically owns the peatland itself. And then they are at the table for conversations around managing waterways in the surrounding area, in particular, and how that relates to access to camps that are out in this area that are accessed by road, and the road goes through some waterways. And so every time there's flooding and they need to divert water, there's a conversation about, well, what is this going to mean for the surrounding wetlands, and in particular the peatland? An interesting tidbit, this picture here that we're looking at, that's broken up into a lot of little pictures with the spring in the center. Researchers have gone diving into that particular body of water, and they got to 25 feet deep, and they still hadn't hit the bottom of excuse me. but they got to this area where it was so thick and murky that they were uncomfortable trying to pursue it further. So they came back up to the surface. But some pretty amazing stuff. The peat itself can be anywhere from a foot or 2 feet deep all the way down to, you could fit a 3-story building underneath some of the peat and still not hit ground underneath. So they're really mysterious and really interesting places.
Do bogs or the swamplands ever contain quicksand?
Yeah, quicksand is a different thing altogether. It's a good question though. It's kind of a similar idea that it's this unstable ground, just depending on how much peat is underneath and whether there's moving water underneath there. Just kind of this idea that you can't trust the surface of what you're potentially walking on. But yeah, quicksand is a different thing. Yeah.
So why are the peatlands so low in nitrogen?
I'd have to go and do some reading for that one. I know they're generally nutrient poor places, and nutrients are built up in soils, and this is a really wet environment, so you can't accumulate soil. So my guess is something related to that. The other part of this is that soil is healthy because of microbes and because of decomposition, where the microbes are breaking down that organic material and releasing the nutrients to be used by other plants in that area. In the peatlands, you have this kind of limbo of decomposition, where decomposition is happening but incredibly slowly in an anaerobic state underneath water. And so those nutrients, there's tons of plant material, really dense plant material that's dead and decaying, but the microbial activity is really slow, so it can't release the nutrients as quickly. I'd have to do some research on nitrogen in particular, because nitrogen is released into the environment through nitrogen fixers, plants that are able to take gaseous nitrogen forms and convert them to compounds that are physical compounds that other plants can use. That's why we use so much fertilizer. It's a physical compound containing nitrogen that allows plants to take off. But I'd have to do some research on what nitrogen fixers live in the peatlands and how limiting that nutrient is, or if it's just that all nutrients are limiting in this area because the breakdown of material is so slow. Yeah, it's a great question.
So can the pitcher plant eat small birds, mammals, or reptiles?
I think the most amazing one there is that it can digest anything that's in there where there's enough surface area of the fluid to slowly break down the item. So it can take down snails and it can take down slugs. So it's kind of amazing. I have to think that the larger the item, beyond a snail or a slug, is just too much surface area and too large. Those particular pitcher plants are about this size. They're like, 3 inches in diameter and maybe 6 inches deep, if not only 3. And the fluid itself is just down at the bottom of the cup. So yeah, I think it's just a limitation of size. But if you could, it's kind of an interesting idea. If you could extract enough of their fluid, is there a limitation on what they'd be able to digest? That's a great question. Yeah, they're fascinating.
Great, thanks for addressing that one. Could you hold the book up again that you were recommending?
Yeah, Swamplands by Edward. Can't read it backwards. Struzik, Struzik. Swamplands. Very fun. I've got this thing earmarked like crazy because I'm a geek and I love this topic, but also because he's got a lot of interesting stuff. But it is dense, so you kind of pick read a chapter and then put it down for a bit and process what you've read.
Great, thanks, Charlie. Unfortunately, that will be the last question that we do have time for today. So I would like to throw it back to you for any closing comments that you may have for us.
Well, thank you everyone for tuning in and letting me talk about something that is just near and dear to my heart. And I'll be continuing on this peatland journey, and I hope you'll join me as well. So thank you for tuning in, and I'll see you in the new year with the Daily Dose. The next one I have won't be until January or February, but check the calendar, and I'd love to have you join again. So thank you.
Charlie, thank you so much for taking the time to present for us today. And I'd also like to thank everyone who tuned in today. If you are interested in information on how you can travel with NatHab, please give us a call at the number on your screen, or you can send us an email at info@nathab.com. Our adventure specialists are happy to help you out. Join us tomorrow for our next Daily Dose of Nature. You can check out this week's lineup, including registration links, on our website at nathab.com/webinars. We did record today's presentation, and we will have the replay available on our website soon. With that, I will conclude the webinar. Goodbye, everybody. We'll see you next time.